Right, hello everyone. So this is a quick walkthrough of the 2020 paper, sections A and B. Okay, so the theory section. Now this is going to be slightly different compared to the 2021 paper, which will have choice. This will not have choice. Okay, but we'll go through it anyway. Okay, as I go through it, I will of course mention any marks that were distributed. So section A, short answers, 5 marks for question 1. So let's quickly go through it. So let A equal 5, let B equal 2. What's A star B? Well, it's 10. Star means multiply. Okay, I know it's JavaScript and you haven't done JavaScript, but the rules still apply. What's A star star B? So what's A to the power of 2? Well, what's 5 to the power of 2 is 25. Okay, A divided by B. What's 5 divided by 2? It's 2.5, or 5 over 2. Okay, what's A percentage? Oh, sorry, what's B percentage A? What's 2 divided by 5? Ooh, this is modulo, remember. So 2 modulo 5 is, well, how many times does 5 go into 2? It goes 0 times remainder 2. Okay, so that's what that is. And then what's plus A? Okay, well, A is 5. Plus A is just like plus equals in Python. So you're just incrementing it by 1. So it's 6. So that's 5 marks. Okay, 5 times 1 for a total of 5 marks. Okay, so that's 5 out of 60. That's, 12% of that question. Right, it's not too shabby. Okay, question 2. Let's have a look. Again, everyone should be getting these ones right. Okay. Many modern laptops have hard disk drives that can exceed 1 terabyte in capacity. If you're buying a laptop, you also have the option of a solid state drive with a capacity of 512 gigabytes. In terms of storage capacity, what do the letters gigabyte and terabyte? What? I literally said it, didn't I? Gigabyte and tera. B-Y-T-E. Okay. 2 marks. 1 mark for 2 marks. Okay, now, assuming that neither cost nor capacity were issues, explain why you might opt for the SSD instead of the HDD. Okay, let's go with a couple of options. So see a bit of room. If there's room, you write into that room. You just don't write one line and happy days. Right, well, SS, smaller, lighter, faster, and quieter. What else can we say? No moving parts, therefore less heat produced and less energy used. I was probably the main one, safe from magnetic fields. Okay, they're the main ones. I can't really think of anything kind of else. I'm sure you could. 3 marks. Okay, I know this is very important. The way they seem to be marking this is, and this follows through the whole thing. 3 marks are given for very good description, clear understanding demonstrated. You'd get 2 marks if you had a basic, if you mentioned one thing probably, or 2 things, you get 2 marks out of 3. And then if you basically just wrote down something, SSD smaller and left it at that, you get 1 mark. So you would get marks for this, but the more you can write and the more you can explain it, the more marks you're going to get, that type of thing. Okay, so on to question 3. So that's not so bad, not so shabby. So hope you can see this. This is where I suppose things can start getting a bit funny, because then you're thinking like, ooh, okay, right. So the program counter is a special register in the processor of a computer. Outline the purpose of the program counter. Okay, so this one is probably where it starts getting a bit tricky, because if you can't figure it out. So the program counter, well, what does it do? It keeps track of where the program is in its cycle execution, I suppose is a better word, execution, and holds the address of the what's the what's the best way to think of it, instruction currently being executed. Okay, it increments by 1 every time an instruction is executed, which makes sense. Goes up by 1. I suppose, you know, how are we looking at? That's a 5 marker answer. Okay, 3 marks, you probably say, you know, increments by 1 every time a new instruction is executed, probably get 3 marks. 1 mark, which just says, you know, keeps a track of where the program is, would probably be a 1 marker. Okay, so the more you can write about the one thing, the more closer you're getting to those 5 marks. Okay, question 4, the World Wide Web and the network infrastructure that supports it allow for seamless transmission of data such as websites, voice applications, and streaming service. This is all possible due to the protocols that it uses. When referring to the World Wide Web infrastructure, what is meant by protocols? Okay, so let's think about this for a second. This is, again, you're getting into the kind of details. So even if you knew nothing about this and you just knew the English language, you'd be able to give some definition. Okay, so it's a set of rules agreed to be followed in order for communication between devices across a network. Okay, that's kind of where you're going with this one. Okay, so it's rules for network communication, and it's agreed. That's the important. Okay, so what you really need there for the full kind of 2 marks, it's only worth 2 marks, okay, is for the full 2 marks, you're going to have to say it's a set of rules, they're agreed. So that's the first bit. That'll get you 1 mark. And what's it between devices for communication across a network? That gets you the other bit of it. Okay, so you just have to be very careful there. Okay. So let's have a look at the next bit of it. What are we looking at here? State the name and purpose of one such, oh God. Okay, one such protocol. So again, listen, there's loads of them we did. Okay, go with the easiest one. Don't get all fancy. Go with HTTP. Hypertext, what is it? Transfer protocol. Okay, what's it used for? It's, I'd give the name. Okay, exchange documents and allows for formatting. Okay, you could do the HTTPS one, which is the same one, we just added it as security. You could do the TCP one, okay, low-level messages into packages. You could do the IP one, routing. You could do VoIP one, used for transmission of voice over internet protocol. You could do any of them, but have 1 or 2 of them in the back pocket so you know what you're at. Okay, if you don't, you can do FTP. Okay, just have 1 or 2 of them in your back pocket. That's all I would say. Okay, you can't remember all of them. Nobody can, but you should be able to understand what a protocol is and what it does. Okay, that's a 3 marker. 1 mark for the name, another 2 marks for the purpose. Okay, so here we go. Here's the fun. So we have ourselves a little half adder. So I hope you can see this. Okay, I'll just bring it down a little bit. The half adder logic circuit generates two outputs, S and C, from two inputs, A and B. What is the value of C when the inputs in A and B are both 0? Okay, so this one you're just going to have to think your way through it. Now, again, I don't know what the protocol, no pun intended, is going to be with regards to, but let's put in what we know. That's an AND. So both need to be the same. That's another AND. That's another AND. And that's a NOT. And what's this one? An OR. Okay, so what's if both are 0? Okay, so if A is 0, then this is 0, that's 0, and that's 0. So the top of the three ANDs is 0. Okay, if B is 0, that means the bottom of that AND is 0. The bottom of that AND is 1, because it's not. If it goes in at 0, it comes out at 1. And the bottom of this one is going to be 0, so, and that one's a 1. So they're not going to work, are they? So if both of them are 0, what is the value of C when the inputs are C equals 0? Because no matter what, AND needs both of them to be 1 in order to do something. In this case, they're two zeros. In this case, it's a 1 and a 0 and a 1 and a 0. Okay? So they're both going to produce a 0. So a 0 or a 0 gives you a 0. You know what I mean? So you're kind of, I want to say you're screwed both ways, but that's what you're looking at there. Okay? What's the value of S if the inputs are both 1? Okay. So let's have a think of this one. Okay, I'm going to actually, we did do the lines. So we've got a 1 from this and a 1 from this. Okay, so you're getting a 1 there, and that's not good anyway. That's a C value. Okay, so let's have a look. Let's try and do this one. Okay, I wonder, can you see both these things at the same time? You can. Okay, I'll just bring it up slightly so you can see. So we're really looking at the S one. Okay, so have a look and see where we go with this. This is going to be a 1, and this one's going to go in as a 1, so that comes out as a 0. Okay, this one's going to go in as a 1 but come out as a 0, and this one's going to go in as a 1. So what's that going to give? These two ANDs, 1 and a 0 comes out as a 0. This two ANDs comes out as a 0 because they're different. A 0 is 0, or you're going to get a 0. So S is 0 for the second one. Okay. Now, marks wise, what are we looking at here? 3 marks. Okay. First one correct, 3 marks. Second one correct, 2 marks, for a total of 5 marks. Okay. Aye. Here we go. Okay, on to Ascii. Okay, so the American Standard Code for Information Exchange, ASCII, is the character encoding standard adopted by the Institute of Electrical and Electronics Engineers in 1963. Why are encoding standards such as ASCII important? Okay, so why are they important? What are they trying to say? Okay, so again, it's kind of like the protocols. It's a set of rules. For communicating between different systems, basically. Okay. So that's probably not enough. You need to write more. So what? Sending data across a network to be interpreted the same way by different computers. Okay. State one limitation of Ascii. Okay. Sorry, that's 3 marks. Okay. One limitation. Let's probably think. Max of 256 characters. Okay. No emojis. Okay. No non-English characters. Okay. So anything like that, 2 marks. I give more than 1. Why is it a maximum? Because you have 8 bits and 2 to the power of 8. That's why. Okay. Question 8. Hope you can see it. So question 7, 8-bit binary, we need to turn it into hex. Okay. Now you could cheat on this a little bit, but don't cheat, please. Okay. It's 5 marks. So yeah, you should be well able to do it. 5 marks. Okay. Lots of different ways to do it. You can go straight, or you can turn it into decimal and turn the decimal into hex. Okay, so what that's it. That's 2 to the power of 0. So 2 to the power of 2 to the power of 0, 2 to the power of 1, 2 to the power of 3, 4, 5, 2 to the power of 6. So what's that? It's an odd number. So 2 to the power of 6 plus 8 plus 3, 75. So we turn 75 into hex. How many times does 16 go into 75? 75 minus 16 is going to be 4, and then 0.68 remainder. 4 16s is 64. So that is 4B. I'm right. Okay, so there you go. That's another 5. That's 5 marks. I mean, you can't really argue with that one, lads. 5 marks. Now, question 8. Ooh, a nice little algorithm. Okay. So, what do we got here? The set below shows a bubble sort, integers. Start by scanning over in 4 passes, complete for pass 2, 3, and 4. Okay, remember, we've done bubble sort. The whole idea at the end of each bubble sort, the biggest number is where it should be, and the next biggest number is where it should be. So look, they've done the first pass to get the 9 there. The second pass, to start with a 5, no change. Okay, so the 5 is going to stay where it is. So you have to then kind of decide, well, what goes next. Okay, so you have no change here. So to be a change here, you'll have 5, 7, and 8. So you'll have a swapsies. Okay, and then you'll still have your 6 and your 9. And then you'll have 5, 7, 6, 8, and 9 because you had a swapsies. And that's that pass done. And then we'll start again 5, 7, 6, 8, 9. And we should end up down here with 5, 6, 7, 8, 9. So let's check. So we'll have 5, still have a 5. Okay. Then we have a 7, so no swapsies there. And then 5, 6, 7, 8, 9, swapsies. And then 5, 6, 7, 8, 9, 5, 6, 7, 8, 9. There are 5 marks. 1, 1, 1, 1, and 1. Okay, very doable. You should all be able to do it. Okay, now we have a set of data here. So we have a set of raw data. We have lots of information. It's 3 problems. Like, there's more than 3 problems I can see, but you just have to list 3 problems. So how much are we going for this one? We got 5 marks. Okay. Okay. Eugene, multiple times. Okay. O father and the A father might not be recognized. What else have we got? In the gender, we have an F with a dot, and we have upper and lowercase. Age, there's a negative integer. And in the time, we have a comma. And okay, so there we go. So question 10. Right, we have to figure out what should have gone in there. Well, listen, what's the start and what's at the end of any HTML document? HTML. What should have gone there? The word menu. Now, this is a list, but again, if you're using your cheat sheet, you should be able to spot it on it. It's a UL. Okay, and then anything that's HTML, it's href. Okay, so I think there's 5 marks for that. Could be wrong, but I think there is. Yeah, with 2, 1, 1, and 1. Okay, again, you know, something you should kind of have an idea about. And question 11. Right. The intention of the JavaScript function is to return a student grade descriptor. 80 and over is a distinction. From 40 to 79 is a pass, and less than 40 is unsuccessful. The code runs without any errors, but it does not return the correct grade descriptor. Outline one way in which the function could be modified. So there's something basically wrong with it. Okay. Well, I can see straight away if. Okay, so the second if should be an else. So if else, so it's either one thing or the other. So if it's greater than or equal to 90, it's distinction. Else, if it's greater than or equal to 40, it's a pass. Okay, that's one thing. Okay, let's see what else we could think of, because I'm not really happy with that. There's probably a couple other things I'm trying to guesstimate on this one. Okay, so what's happening here is it's activating the pass even if they get over 90. You could put if for the second, put an else if between 40 and 80, and then else unsuccessful. You know what I mean? So you've got your second. So the if there needs to be changed to either an else if you're just kicking it out there, or an else if and then put another else, so you can get the 40 to 80 group as a pass, the 80 plus group as a distinction. But again, it's just a matter of kind of telling them what you think is going on. Okay, again, 5 marks, but you need to kind of put a couple of bit of descriptive elements in there to kind of help them out. Okay, and the last one, I think, yeah, before section B. So we'll do section B the next video. So question 12. Okay, so what we have here is the traveling salesman problem is commonly used in study of algorithms and pairs formats as following. Given a list of cities and distance between each pair of city, what is the shortest possible route that each visits each city once and returns to the original city? Why would heuristics be considered a good approach to solving such a problem? Okay, so heuristics, we talked about this before. Okay, we'll find finds the best solution. Okay, when it would take too long to calculate the actual solution. So there is probably an actual solution, but the best one they could go with, the one the most efficiently that's going to do it in the shortest amount is not always going to be the best. Okay, so it's a rule of thumb, or educated guess. That would give you the best kind of. So again, 5 marks, what they're looking for there. Okay, you can put a bit more spin on it if you want, but that's basically it. Okay, so that's section A done. I'll do section B the next video. Okay, goodbye.